Okay. So we're going to look at factoring perfect square trinomials. If you see a trinomial, and if you notice that the first term is a perfect square, and the last term is a perfect square, it might be a perfect square trinomial. To find out if it really is or not, look at that middle term. If that middle term is 2 times the first term and the last term multiplied together, then it's a perfect square trinomial. Okay? And that's kind of what this is showing here. So is x squared a perfect square? X squared is a perfect square. Is y squared a perfect square? Yes. What do you square to get x squared? X. And what do you square to get y squared? Okay. What's x times y? Double it. That's the middle term. If it looks like that, then it's going to factor into x plus y. How do you know if it's plus or minus? Well, you just look at that second term. Okay. Now, I've been factoring probably in my whole life 2 or 3 hours, right? Or maybe a little bit longer than that. Maybe since like 7th grade. I will honestly tell you, I've probably never really paid attention to perfect square trinomials. I just factor it the way I factor any other trinomial. If you see it and it helps you, great. If you don't see it, that's fine too, because you can still use the snowflake to factor, and it's going to give you that perfect square answer. Okay? Here are some that are perfect squares, and we'll walk through it and see how this works. So letter A, 16p squared minus 40pq plus 25q squared. Is 16p squared a perfect square? Yes. What do you square to get 16p squared? 4p. So this came from 4p squared. So it is a perfect square. 25q squared, perfect square. What did you square to get 25q squared? So if I took 5q and squared it, that's where that comes from. Okay, if I looked at just, and I'm not going to walk through it this detailed every time. I'm just showing you how to see if it's a perfect square trinomial. If I took a 4p and 5q, just those two pieces, and multiply them together, I would get what? 20 PQ, right? What happens if you double 20 PQ? Which is exactly what that is. Okay? So I know that this is a perfect square trinomial, and it factors into 4p and 5q. Oh, I didn't put a sign there for a reason. Squared. What sign goes there? Whatever this sign is will come on down. And if you were to FOIL that, you would in fact get what I started with. Thoughts on that? I'm not going to go into that much detail on the next one. Okay. Part B, 36x squared y squared plus 84xy plus 49. Is the first term a perfect square? Where did 36x squared y squared come from? Okay, so it came from 6xy. Is 49 a perfect square? Yes, it came from 7 squared. And because this middle guy is a plus, let's bring it down. And then we'll put a square there. Now, is this true? Is it right? Well, I know that 6xy times 6xy does give me 36x squared y squared. And I know that 7 times 7 gives me 49. But does 6xy times 7 times 2 give me the 42? Up to the 84. Give me the 84. Does it give me the 84? Yes. So this is factored completely. Okay. Any questions on that? And please ask if you have them. I know it's hard to, in a small class like this, for people to ask questions because you get scared, but I would hope maybe you're more comfortable in a smaller environment asking questions. I don't know. Huh? I will. You know, I'll make fun of you if you ask a question, but that's how I roll. No questions? Okay. Do you remember these? Difference of squares, sum of cubes, difference of cubes. Y'all remember this from last semester? Yeah? Is there a formula for sum of squares? Is there a formula for sum of squares? No. So if you have a perfect square plus a perfect square, it doesn't factor. You should know these. I want to say that last semester we used A's and B's here instead of X's and Y's. I mean, maybe M's and N's. I don't know. But it's still sums and difference of squares. Sums and difference of cubes, sums of squares. Difference of squares. Four m squared minus 9. Does 4m squared minus 9 look like one of our rules? What's it look like? It looks like a difference of squares. Okay? In fact, everything on this page is difference of squares. So remember, difference of squares is going to be x squared minus y squared equals x plus y times x minus y. So once you determine what x and y are, you got your answer. What do you square to get 4m squared? So this is 2m squared minus, and what do you square to get 9? 3. Which means 2m is my x and 3 is my y, and I apply the formula. You don't have to write all this down. I'm just being detailed. What does this factor into? Piece of cake. Do y'all write it down as the perfect squares or no? Does anybody write all this down or no? Anybody? Okay. Part B. 256k to the fourth minus 625m to the fourth is 256k to the fourth a perfect square? Yes. What do you square to get 256? 16. What do you square to get k to the fourth? 25 times 25 gets you k to the fourth. What do you square to get k to the fourth? K squared. Minus. Now I'm with you. What do you square to get 625? And what do you square to get m to the fourth? So therefore, this is a difference of squares, and it factors into the first guy, which is 16k squared, plus the second guy, which is 25m squared, times the first term minus the second term. Am I done? No. Why not? Which part? Yeah, we can go further with the second part, which is why I always write the plus first. Okay? Because if you write the plus first, it does, a sum of squares doesn't factor. So I'm just going to bring it down. (16k squared minus 25m squared). You told me that factors. It's a difference of squares. What does it factor into? 4k. What? Let's do the plus first. 4k plus 5m times 4k minus 5m. Okay. Is it wrong if you write the minus first? No. I just do it this way because I'm very consistent and do it the same way every time. Okay. How about part C? Y'all are smart. Give it a shot. Perfect square minus a perfect square. See what you get.
That's a whole lot of brain power.
No, it's not. Come on, let's go. I believe in you.
Two different things. I'm looking because we got something completely different. This is right.
Yeah. Write that as 2c squared. That way you can see what your x and your y are. Yeah, makes yeah, we're on part C. We try to follow the alphabet, A, B, then C. You're on C, right?
Oh. Oh, yeah.
If you did this, then you've got 2c squared squared. That's going to give you c to the fourth. So that square was right, but the one on the inside needed to go bye-bye. Using notability? Anybody using? No, okay. Notability is, have you ever used notability? So you can have your PDF or whatever and you're taking notes on it, and you can press a button to actually record. So it's recording audio while you're writing, and then you can go back and play it back, and actually you'll play back the audio while you're writing, so you can like fast forward through and you can see what you're writing. It allows you to go back to see what they were saying when you wrote that down. It's pretty cool. It's not a free app, but it's pretty cool. Was GoodNotes free? Yeah. Okay, how are we feeling about letter C? Are we crashing and burning? You're thinking too hard. If you're crashing and burning on part C, I'm serious, you're thinking too hard. Okay? Due to space, I'm going to go ahead and erase B. All right, so starting off with C, do I have a difference of two squares? Is my first term a perfect square? Yeah. Is A plus 2B squared a perfect square? It's kind of in the name, right? So this is a perfect square. So I'm just going to write it down. A plus 2B squared. Is 4C squared a perfect square? Yes. What do you square to get 4C squared? 2C. Does anybody have a question with that step? Okay, guys, this right here, that is my X. This right here, that is my Y. So let's just apply that rule. It factors into X plus Y. What's X? A plus 2B. Plus, what is Y? 2C. Times, what is X? A plus 2B. Minus, that's what the rule says, what is Y? How hard was that? Okay, just because there's a bunch of extra junk there doesn't mean it's more difficult. We're following the exact same rules. What is X? What is Y? Add them together, subtract them. Difference of squares, done. Thoughts on that? Okay. How about D? Does that look, what are we doing on this slide? All we're doing is difference of squares. Does part D look like a difference of squares? Do you see two things being subtracted? Yes or no? Or do you see a bunch of other junk with it? There's a bunch of junk there, right? Okay. What if we looked at just this piece of it, though? Does that factor? Does x squared minus 6x plus 9 factor? Yes, it does. What does it factor into? No. X minus 3 squared, right? X squared's a perfect square. 9's a perfect square. Right? Middle term's 3 times x doubled, but it's negative. Minus y to the 4th. Have I done anything crazy? All I did in that first step was I replaced this trinomial with this binomial squared because x squared minus 6x plus 9 is a perfect square. Do I now have a difference of squares? Is x minus 3 squared a perfect square? Yes. Is y to the 4th a perfect square? Yes. What I have here is x minus 3 squared minus y squared squared. Let's write our answer. This is a difference of squares. And again, all I care about is what's being squared minus what's being squared. Okay, so my answer is going to be x minus 3 plus y squared times x minus 3 minus y squared. Questions, comments? How we doing? We can nod our head yeses. Okay. How about the last one? Thoughts? Now, second period figured out. So I think y'all should be able to figure it out too. What do you mean? Is it x squared? It's a negative x squared. Okay. So are we going to separate it like the last time? Yeah, in a sense. But can you factor negative x squared plus 6x minus 9? What's the problem with that? Right. When you're factoring, the leading term be positive, right? I know what you're trying to say, but you can't just multiply. Instead, we factor out a negative 1, which is the same concept. So I have to take a negative 1 out of this. So what I'm going to have then is y squared. Here's my negative sign. If I factor a negative out of negative x squared plus 6x minus 9, what happens? Okay, so all the signs change, right? That's all that happens. If you factor out a negative 1, your signs change. So this becomes x squared minus 6x plus 9. Y squared minus. What does x squared minus 6x plus 9 factor into? Maybe x minus squared? Okay. Looks like a difference of squares to me. I've got this guy, and I've got this guy. And those are my pieces. But pay attention to your signs. This is very important. Okay. What's the answer going to be? Not y squared. So it's y plus what? X minus 3 times, let me ask you this. Is this answer correct? Why not? What negative sign? Yeah. Well, okay, pay attention to what you're doing here. You're taking y plus this binomial. So technically, there should be parentheses around that x minus 3. Now, do those parentheses mean anything to us? Y plus, boom, x minus 3. Parentheses do nothing for us, do they? What about that second term? Right. This is y minus x minus 3. I'm subtracting the whole x minus 3 from the y. Okay? Now let's write the final answer. The first group, I can drop those parentheses. Y plus x minus 3. The second group becomes y minus x plus 3. If you wanted to write the x first, you could do that. If you wanted to factor out a negative 1 in that last group to make that x a positive term, you could do that. I would just leave it right here, though. Okay. Questions on this? It's a little deeper than what we looked at last semester. I know that. No questions indicates that y'all are all experts on this now. Okay. Get out a piece of paper, let's take a test. Just kidding. All right, sums and differences of cubes. First problem. X cubed plus 27. Since all of these are sums or differences of cubes, before I get started on any of these, I'm going to go ahead and write the formulas for those. Is it okay if I use A's and B's instead of X's and Y's for my rules? There's no A's and B's here, so I'm going to use A's and B's. I'm going to write both of the rules in one shot. If I had A cubed plus or minus B cubed, it will always factor into A same sign B times A squared opposite sign A times B, always plus B squared. That's what that formula sheet showed way back 2 slides ago, right? But I wrote it in one setting. All the terms are the same. The only differences are the signs. And y'all remember what we used to remember which sign goes first? 4-letter word. Girls know the word better than boys, especially in high school. Soap. What that tells me is when you're factoring a sum or a difference of cubes, the first sign is always the same. Plus goes with plus, minus goes with minus. The second sign is always opposite. Plus goes to minus, minus goes to plus. And the third sign is always plus. Soap. Okay. Letter A, x cubed plus 27. Is x cubed a perfect cube? It's kind of in the name, right? So this is x cubed plus, is 27 a perfect cube? Yes. What do you cube to get 27? 3 cubed. What I have done is I've identified A to be x and B to be 3, and now I can apply my formula. Okay. This is a sum of 2 cubes, which means we're going to go across the top here. What is my A? X plus B, which is 3, times, what is my A squared? X squared. Opposite sign, so minus. What is A times B? 3x. Always plus, what is my B squared? And we're done. As I've said before, do not try to factor that trinomial because we followed a rule to factor a sum of cubes. And that rule told us the answer, which tells us that that trinomial does not factor. Okay? Part B, m cubed, perfect square, a perfect cube. It came from m cubed minus, is 64n cubed a perfect cube? What do you cube to get 64? And to get the n cubed, I've identified my A and my B, so I can write my answer using the formula. And recall that you can use a 1-page cheat sheet writing on both sides, even in this class. Okay. Final answer. A is m, same sign, so minus. B is 4n. Just like this class to some of y'all, it's 4n. Maybe a different 4n. A squared, m squared. Opposite sign, so plus. A times b, 4mn, because we like our alphabet. Keep it in order. Always plus b squared. What? Okay. You're probably not the only one that's done that before. Sometimes we have to think about, is it P or Q? I don't know. Part C. 8q to the 6th. Is 8q to the 6th a perfect cube? What do you cube to get 8q to the 6th? 2q squared cubed is 8q to the 6th. Plus, what do you cube to get 125p to the 9th? 5p cubed is 125p to the 9th. I've identified my A. I've identified my B. It's the top. Write the answer. I missed something on this term right here. Remember this right here is going to be a squared. So if you square this, what happens if you square this whole thing here? What do you get there?
You want to fix the Q? Yes, because you're going to give me my paper Q.
Can you read that?
Yeah, this is cool little scribbly scrabble. For Q.
Okay. Following the formula, what is my A? 2q squared. This is a sum, so same sign. B is 5p cubed times What is a squared? 4q to the 4th. Opposite sign, minus a times b. 10p cubed q squared. Always plus. What is b squared? Went off the paper? Okay. Questions on that? Yes. When you raise a power to a power, you multiply them. Okay. When you're just multiplying, you add. Because go. So if I had p to the 3rd to the 4th, that means p to the 3rd times p to the 3rd times p to the 3rd times p to the 3rd. Those are the same, right? Okay. So because these are the same, my answers better be the same. So when you have a power to a power, you multiply. So this would be p to the 3 times 4, which is p to the 12th. And when the base is the same and you're multiplying, that's going to be p to the 3 plus 3 plus 3 plus 3, which is also 3 times 4, which is p to the 12th. Any other questions? Okay. Looks like a good place to start tomorrow.